All right. Hey guys. Hello. Um, we're gonna be studying a bit of Rust today, and the reason why we're studying Rust is because it's the primary language that is used for programming smart contracts or programs on the Solana network. That's my motivation for studying Rust. So yeah, let's go ahead and just run through the examples provided on the Rust website. Yeah. Okay. So let's just get straight to it. Alrighty. Okay. So we're gonna be learning a bit of Rust. Get familiar with the syntax. So I've coded a bit of Rust already back in February and April, but if you don't do it every day, you get rusty, I guess. So let's try doing learn Rust by example. So I think that's gonna be good because they have the Rust compiler straight from the website. So yeah, let's actually do that. But before we do that, let's just slide this follower goal just right here. Just make that into a small snippet here. That's good. Yeah, okay. Let's get started. Rust is a modern systems programming language. Safety, speed, and concurrency. Runnable examples. Oh, hi. I already have Rust set up. You can check the source code of this site. Let's begin. Hello world. I think I've done this already before. Make a function, run println. I think for the sake of just feeling very comfortable with Rust, I actually want to build it locally. So I'll just make a simple project here called Learn Rust. It's going to be our sandbox for the things that we'll be studying. Let's go ahead and make a main.rs. I think that's how they name their programs. Let's just make a main function and just copy the whole thing. Semicolon. And then what do we do to actually run it? Main.rs. So we compiled it, and then we can actually run main. Excellent. Oh, hi. Okay. All good. Okay. So pro comments, I think this is trivial. It's just the common / and the asterisks. That's trivial. Let's move on. Formatted printing. These are macros. I've read a little bit about macros. They expand into actual Rust code. So it opens up an opportunity for some meta programming. So, okay, that's perfectly fine. Okay. All parse text in the same fashion. This is how you notate where to put the variables as long as they follow a certain interface. I don't know what it's called. Format display. So if it implements the format display interface, then it can be displayed. I'm not sure what this means actually, this notation, but we'll get to that as it continues to explain its stuff to me. Okay, so there's just formatting stuff, simple printf related things. I don't have to memorize this. Standard format contains many traits. I'm not entirely sure what traits means. I've read this before, but it didn't make sense. What are traits? Okay. What are Rust traits? A group of methods that are defined for a particular trait. So this is basically interfaces. A trait is an interface. It's a group of methods that are defined for a particular type. Yeah, implementing an interface or a trait. Oh, hi, trivial. All right, let's go. Mhm. Implementing format display automatically implements toString trait, which allows us to convert. So this is the interface. This is the trait, right? This is the interface. If you implement this, it provides this function. Okay. Da 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 da. Let's go. Debug. All types which wants to use requires an implementation to be printable. Mm-hmm. Mm-hmm. You can derive debug. So debug is an interface. Excuse me. Okay, let's move on. So derive what does derive do? Rust derive. So it's a way to lift implementation from somewhere else. The derive attribute allows new items to be automatically generated for data structures. It uses the meta list path syntax to specify a list of traits to implement, paths to derive macros to process. For example, the following will create an implementation item for the partial equality in clone traits. For foo, the type foo, and the type parameter t will be given the partial equality or clone constraints for the appropriate implementation. The generated implementation for partial equality is equal to implementation for t that implements partial equality for some foo. For foo, so this is saying this is the type of t. It must follow the partial equality. So if we're trying to find the equality of some foo, then and you have a reference to yourself and the other one, and you just check if a is equal to a and b is equal to b. It's not equal if this one is not. Yep. Okay. Procedural macros. I think I'm getting ahead of myself, but this is beyond me, and that's how we learn. So let's just read and figure this out. Okay. Derive macros define new inputs for the derive attribute, which is so these are attributes. Okay. So there's an attribute, and then this is a new input. Okay. These macros can create new items. What's an item? Given the token stream of a struct enum or a union. So this is the token stream of a struct enum or union. They can also define or derive macro helper attributes. Custom derived macros are defined by a public function with a proc macro derive attribute. Okay, process macro derive for answer function. And this is saying this and a signature of token stream to token stream. The input token stream. Oh, I shouldn't have clicked that. The token stream is basically the code, right? So it gives you the input. So you're programming the program. Okay. 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 The following is an example of a derived macro. Instead of doing anything useful with its input, it just appends a function answer. So we parse this and then we unwrap it, and then it's still a token stream. And using the set derived macro, use proc macro examples, answer fn. We derive the answer fn. because by doing this, so there is some input, right? The input here, the token stream, is actually this one. I think this is the input. Yeah, and then this gets replaced with this one, or is appending this one. Okay. Derive macros can add additional attributes into the scope of the item. So let's read what an item is. I think an item is just a piece of code. An item is a component of a crate. Items are organized within a crate by a nested set of modules. Every crate has a single outermost anonymous module. All further items within the crate have paths within the module tree of the crate. Items are entirely determined at compile time, fixed during execution, and they are read-only. Possibly may reside in read-only. So they're definitions, basically, things that shouldn't change. And I think this, making this remain the same, is how likely the language benefits its optimizations. Some items form an implicit scope for the declaration of sub-items. In other words, within a function or a module, declarations of items, in many cases, can be mixed with the statements control blocks. The meaning of these scoped items. So what I'm understanding here is within a function, right, you can have other declarations. You can have, can you have other functions defined inside another function? Let's see. Test. Well, it works, right? And then we do test. Is that allowed? Well, it works. So he's saying that within a function, right? Within a function or module, declarations of items, like another item, can be mixed with the statements control blocks. So if we, for example, say if, I don't know how if statements work here, so let's just see how this works. This will actually catch the problem in runtime, I mean in compile time. Unnecessary parentheses. Okay, let's take that off. Okay. Expected function test, found attribute macro test. Aborting. It's not a function. But if we say this is true, expected function found attribute macro test. So it's not within the scope because it's here, right? Okay. So is there a way to, yeah, of course, this is the scope of that function. Of course, that makes sense. Now I just want to know if there are Rust function receivers. Can you define that? Can you do that? Can you do something like that? Yeah, a function is not an expression. So they can't do that. But you can do it from a macro perspective if you're using the derived stuff. Because it's, yeah, it's programming something else. Okay. Alright, let's just go back here. Okay. The way to define helper attributes is to put an attributes key in the proc macro derive attributes helper. Derive helper attribute. Okay, I want to try this out. So we made a new struct, and then it has some kind of helper thing, because it was able to derive something new. But I actually don't know how to instantiate structs. How do we instantiate structs? Let's move along. We'll probably see it later. How to define a struct first. Oh, they use the let keyword. Okay, let object is equal to struct. Does that work? Can't use procedural macro from the same crate that defines it. Okay, let's follow along, see what this means. Okay, can't find crate for proc macro examples. Okay, I think these are the parts where I just have to skip over and figure this out later when I've got the foundations of it down. So we're gonna skip over. Yep, okay. We'll pop the stack. Okay. We don't want to get stuck here too much. Okay. Let's try that. Okay. I don't know what this apostrophe A means actually, but we'll see. Field is never read. That's just a warning. The person has a derived implementation for the trait debug, but this is naturally ignored during dead code analysis. Okay. But then it pretty prints it. It's pretty cool. Okay. What if I don't want to pretty print it and I just want to put the thing like this? What happens? Okay. So it's just not, just doesn't have its commas. All good. Okay, moving on. Display format debug hardly looks compact and clean, so it is often advantageous to customize the output appearance. This is done by manually implementing display, which uses print marker. Implementing it looks like this. We import stuff using use and the format module to make it available. We define a new structure for which format display will be implemented. This is a tuple struct named structure that contains an I32. To use the marker, the trait format display must be implemented manually for the type. So let's go ahead and actually type this out. So standard format structure I32, and then we say format display for structure, and then we define a function inside of that implementation called format. It has a reference to the self, and it has a mutable formatter which returns a result. And then you use the formatter, and then you write this one, and then you do self. We just present the first element. It's a tuple, say. Alright. Display may be cleaner than debug, but this presents a problem for the standard library. How should ambiguous types be displayed? For example, if the standard library implemented a single style for all vector of t, what style should it be? Would it be either of these two? Vector of path? No, because there's no ideal style for all types of the stat. The standard library doesn't presume to dictate one. Format display is not implemented for vec of t or for any generic containers. Format debug must then be used for these generic cases. Okay. This is not a problem though, because for any new container type which is not generic, display can be implemented. Use standard FMT. A structure holding two numbers, debug will be derived, so the results can be contrasted with display. So we have derived debug, and then we have min-max I64, and then implement display for min-max. So we're trying to implement this interface for this struct. And if this is the func, then we write the implementation, right? So let's do it again. Like, it's very convenient for me to just run the code here on the website, but unless I actually type down code, I'm not gonna get the muscle memory of what things look like. So I'm just gonna go ahead and just type it all over. I think that's part of the learning that I need to familiarize myself with. It's actually this one's doing a shitty job of how to get started, I would say. Okay, so this looks familiar. I've done this before. And then we write on that formatter, and then it looks like this, some tuple, and I pass self.0 and self.1, right? And then we put the derive. So we defined a new structure that has two floating points. And we put some additional implementation for it for deriving the debug. And then we implement display again for that new structure. And we do, again, I have a reference to myself. I have a reference to f, which is a pointer to a mutable formatter, which returns a result. And I'm just going to use the formatter to say that this is x and this is y, and then just reference them. And when I have my main function, I can say that the min-max is equal to min-max 0 and 14. Print ln compare structures. Okay. Display. So this one uses display, and then this one uses debug. Okay, I want to know what that looks like. Oop, we gotta close that. So if you use display, that's exactly how it's going to be displayed. But if you derive the implementation for debug, then it just shows the default implementation. Okay, what about the point2D? So we're gonna just slap this one on. The big range is big and the small is small. Well, what are the big and the small? Okay. I want to write it down because I'm not so familiar yet with defining functions on Rust. So let's just pick up this XP. This is the baby XP I need to get. Okay. Print ln, the big range is big and the small is small. Small, small range. Big, big range. Let point to D. Compare points. I think this is the part where you're like, yeah, I just gotta cut the carrots and drop the stuff. Wait, watch it, and you know, just get to the motions through it. Have the missing curly brace again. And then we want a semicolon here. If you already know it, why don't you do it yourself? Okay. This needs a print line. Okay. Compare structures. This is display and then this is debug. The big range is -300, small range is -3 to 3. Compare the points to display it. We use this one, which follows the display implementation, which is just this one, right? And that's why it was displayed as XY. And then when we debug it, it looks like this one. And we can actually put a hashtag here so that these would be pretty printed. Okay, we're learning. Okay. I'm gonna be back. I'll just make this quick. Be right back. All right, we're back. Let's go. Okay. Let's get back to work. Okay. Implementing display for a structure where the elements must each be handled sequentially is tricky. Problem is each write generates a format result. Proper handling of this requires dealing with all the results. Rust provides the question mark operator for exactly this purpose. Using question mark on write looks like this. Try a write to see if it errors. If it errors, return the error. Otherwise, continue. Okay. So let's go ahead. Make another one. List.rs. Right. So use std format struct list vec. So I would actually so people might actually ask me, why are you actually writing down the code rather than just copying pasting it, right? It's for the same reason why you would watch professional Dota players last hit, and you go in game and you do your own last hitting yourself. It's the mechanical execution that you need to practice. It's not just knowing the concept or trying to understand the concept, but actually putting in the legwork, or in my case, the finger work, to actually learn what needs to be done. So yeah, you just get ahead and you just practice that. So implementation display for list. Okay. Now we want to implement format self f mutable formatter format result, and we say that there's a vector and it is the first element. Extract the value using the tuple indexing and create a reference to the vector. So there's a list of vectors. A list of vectors, isn't that kind of, that's a lot. A vector is already a set of numbers, a vector of numbers, and then you have a list of numbers. Oh, hi. Yeah, that's why it's confusing. Hi. So what we're gonna do is we're gonna write on the formatter, and we're gonna present it with a bracket and close it, and then we want to do some for loop. So this is the first time I'm actually doing a for loop in Rust, so this is pretty interesting. So iterate over v in vec. So vec is our vector. Vec is our vector, right? It's a vector of I32, and then we get the iterable, what do you call this? Your iterator, right? You get your iterator, then you enumerate over it, and then you can do a for loop over it. Then you have the count or the index and the v. So if your count is not equal to 0, then you would like to write on the formatter a comma and just continue. Otherwise, it's not otherwise, actually, it's in addition to, you just display the value. Then you present the actual value and keep going. When you're done, write on the formatter the close bracket. There we go. I'm not sure why this doesn't have a semicolon. Does it even matter? No, it doesn't. Implicitly returns empty as its body has no tail or recursion. Okay. Remove the semicolon. So there's a reason why the semicolon does not exist. Okay, I think the reason why the semicolon doesn't exist is it's no longer a statement, it is an expression. And this results to, if I understand correctly, it results to, show me there's, yeah, it's a result. It's a format result, right? And if there isn't any semicolon, I think that means that this is the same as doing return. I think this is the same. Let's see. Consider adding a main function. Okay, it is considered. There we go. There should be a semicolon there. There we go. So this is functionally equivalent to this one. It's exactly the same. Okay, we're learning. Okay, if there's no semicolons, usually means that that's actually the return value. Okay, we picked that up. All right, moving on. Try changing the program so that the index of each element in the vector is also printed. Yeah, we can do that. We would also present here the value like this, and then we say count, right? 0, 1, 1, 2, 2, 3. All right, let's go. We've seen that formatting is specified by a format string. The same variable foo can be formatted differently depending on which argument type is used, X versus O or unspecified. The formatting functionality is implemented via traits. So now we're being introduced to the concept of traits. So let's put here formatting. And just for the sake of simplicity, we'll make this 1. And we'll make this 2. 3. Go to formatting. Okay. Formatting is implemented via traits, and there's one trait for each argument type. I think another thing I wanted to highlight is like just manually writing down what's actually written on the left side is one of the simpler parts, right? It's one of the easier XPs to gain. So it's not something to actually run away from because it's the easiest thing to do. You just have to copy it. You just need to get over that kind of, I'm beyond that. I'm above that already. And just get familiar. It's just the way to learn, I guess. At least that's what I believe. I want to display the city. No semicolon means it returns. So an if is actually an expression? Whoa. Well, this is a lot more, I would say, verbose in the sense that a newbie will really understand what's going on here instead of the very cryptic JavaScript way of ternary operators, right? This is much better readable in comparison to like what do these symbols mean? What do these symbols mean, right? This is much better. So I want to write to the formatter this value 3 decimal degrees. I'm not gonna look for that circly thing anymore. Degrees. Greece, and then again. So that's 6 variables. Self.name, so this is my city. Absolute value. There we go. Oh, hi. And if we are deriving this, debug struct color red u8 green u8. What's this? Parameters for the display? Okay, let's see. For a city in a certain list. Oh, so that's how you name it. Hi, Dublin. I wonder if these are actually legit values. You know what? Let's find out. Let's find out if these are actually legit values. Google Maps. Okay, where are we? We are in Dublin. Okay, that's pretty good. Pretty cool. That's confirmed. Well, of course, if you were the one actually documenting this, you'd actually give it some legit stuff. Okay, I'm not gonna type these. I see. All right, let's just type it down. Type it down. Let's just get familiar with the syntax. 5995, longitude 1075, city name Vancouver. Yeah, I'm just going against my my laziness. But if you don't grind it out, you don't get the XP. So then you want to get an iteration of it, and then you want to print everything. A pointer to a city. Why is it a pointer? Or dereferenced? I don't know, we'll see. Let's get colors. Color red 128, green 255, blue 90. Oh, getting sleepy. Would be nice to have a nap. Can actually nap. I think a nap sounds really good. Probably after this one. I'm curious really why it has an asterisk there. I don't know why that's the case. Rust-C. Multiple input file names. Aborting. Ooh, why don't I ever close my curly braces? I think I'm pampered in a certain way because of that. Okay, so it's 53 degrees north, 6.260 degrees west, right? It got formatted, and that's how formatting for structs would look like. What is it trying to teach us? Add an implementation of the format as well. So the above displays as. I think this is simple enough. If we wanted to change the display for the colors, then we would. Oh, hi. He basically didn't give us the answer this time, but we can just fill it up. If we want to display for color, then we define a formatting implementation which has a reference to self, and it has a reference to a mutable formatter where the format is result. And what we do is we want to write we say RGB parentheses number, and then I think it's X. And then we pass in self dot red, green, blue, and then I think it's just like this. Self dot red, green, blue, something like that. I think that's what it's supposed to do. And then if we change this one, RGB 80FF5A. I think this has to be capital, maybe. There we go. But then how do I make it size 2? Does this work? 3FE. It's correct, but let's read the formatting traits so we can format it the way we want it to be. Upper hex. Okay, I think I'm doing it right, but why is it not showing the way I want it to show? 80FF5A. We want this bad boy to be a little bigger. I mean, it has to be like 2 character wide. That's what we want it to be. The alternative actually is we shift the values. That's another option. This really means that I need to get better at understanding my bytes. Because I'm getting really close. Yeah, okay. So Rust left shift. Can find value red in the scope. My bad. Okay. Is this how you define a mutable variable? Rust, how to define a mutable variable. Attempt to add with overflow. Does this work? Oh, okay. So we go like that. Looks like TypeScript. So many errors means that it's really safe, I guess. Let's see. Oh, there's the example already. Does that work? Fewer messages interpreted as generic, not interpreted as shift. So we need to parentheses these, I think. There we go. 2, 4, 5, 6 is this expected? I don't think so. I think I should do it by 4s, I think, yeah. Yeah, something's wrong with my math here. If we left shift once, that multiplies it by 2. Yeah, 1 left shift is equal to multiply by 2. So if your number is 1 times 2, it becomes 1, 0, right? But if this is hex, and then I say I have 4, and then I do 8, what does this become? This is 4 if I left shift by 1, what does this do? 4 becomes 0, 8, right? But if I do left shift by 2, this becomes 4 squared, which is 16, 16, which would be F0. I mean 1, 0. This is binary. Oh, so we should do this as this one. Okay. There we go. Now if I want this one, and then this is my question, like how many bytes do I need to shift to make this one become 0400? What is the value of this one? This is 4. What's the value of this one? 1, 16, 256, 256, 1024. So how do I go from 4 to 1024? 4 squared is 16. 4 raised to 4 is 4, 16, 64, 256. So I need to do 5 shifts, I think. This is 5. 4 raised to 5. Yeah, 4 raised to 5. Is this making sense? I think so. So this should be 10. This should be 5. No, something's still wrong. Okay, 402. I think this is getting to be too low level, which I should just be using the formatting that is provided. I feel like. Oh, there we go. This is number 02, and then number, it should all be here. There we go. Ta-da. We need more. Ta-da. Okay, we don't want the hashtags. Ta-da. There we go. We're done. Yep. I was overcomplicating things, and I recognize that, which is Gucci. Okay, let's just copy the degree sign there. Now it's exactly the same. There we go. Got that output. RGB. Yep. Oh, I wasn't reading these hints. Huh, no worries. At least I read the documentation. Anyway, I think that's gonna be it for now. I'm getting a little drowsy. But yeah, that's a good enough start. Do a shitty job. Yeah. Well, I hope you guys enjoyed a little bit of wandering around and figuring out how to do Rust programming with me. Let's do it again another time soon. Bye-bye.